Okay, so let's read number 7. Number 7 says, what is the wavelength of X-rays having a frequency of 4.8 times 10 to the 17th hertz? Well, first of all, like I said before, the math is not the hard part, correct? It's knowing what the problem is telling you, because word problems are hard. It doesn't matter if I give you an easy word problem or a hard word problem. As soon as I throw in words, we freak out. Okay, so let's try to dissect a little bit. Number 7 says, what is the wavelength? So first of all, we are solving for wavelength, but I need to know what the variable is for wavelength. So what's the variable for wavelength? It's the squiggly line of the line, correct? So my wavelength looks like that, correct? So that is what we are solving for, right? And our frequency is 4.8 times 10 to the 17 hertz. What variable is that? It looks like a V with a little tail. And hertz, that's a unit we don't recognize. What's a hertz? What's another way to write hertz? 1 over S. Why would it be beneficial for us to use 1 over S versus hertz? Because then we can see it canceling out. Plus, we're familiar with using seconds. We're not familiar with using hertz, correct? So now let's see if we can do the problem. Now, we have two equations. We learned that C is equal to wavelength times frequency. And we also learned that energy is equal to our Planck's constant times frequency, correct? So, remember in physical science when I made you, me or Miss Tinklepaw made you list your variables? Did we do that to be mean? No, we did that so that you could see what you're solving for, you could see your variables, and you could see what you need to do. So now I have listed my variables. Next, I need to find an equation, correct? I need an equation that has wavelength and frequency in it. So am I going to use my C equation or my E equation? C. So my C is equal to my wavelength times my frequency. And now I've done the hard part, haven't I? Yeah. The rest of it is easy. I've identified my variables. I've figured out my units. Now I just have to plug them into a calculator, right? So what is C equal to? Did I just pull that number out of thin air? No, it's a constant, and it is equal to the speed of light. Yes. Speed of light. We set that equal. Wavelength is what we are solving for, times our frequency. Do what? Okay. Now all we're doing is algebra, correct? We're not even doing algebra 2. We're just doing algebra. We have to get our wavelength all by itself. So how do we get our wavelength all by itself? You divide by 4.8 times 10 to the 17th. What you do to one side, you have to do to the other side. Since I have rewritten my hertz as 1 over S, it helps me to see that my seconds cancel out, correct? So now we have to do the math, which is our next mistake we are going to make. So, do you remember back when I taught you scientific notation and I taught you how to put it in the calculator and it went in one ear and out the other? And then yesterday or Friday when we were trying to do all those practice problems, you were putting it in the calculator as times 10, caret symbol, exponent, which is fine. If you want to put it in the calculator as times 10, you have to use parentheses. If we're not very good at parentheses, you need to learn how to use your exponent key. So on my calculator, the exponent key says EXP. On the graphing calculators, it's second and then the comma button. It looks like EE. And I think it's EE on the other calculators too. So now all we're going to do is punch this in our calculator. So I'm going to do 2.998 exponent 8 divided by 4.8 exponent 17. And I'm going to get 6.2458333 times 10 to the negative 10. How many numbers should I keep? Okay, look right here. How many significant figures are right there? 3. So my answer can have 3. So my wavelength is going to be equal to 6.25 times 10 to the negative 10th. And what's my unit? Meters. So now we need to think to ourselves, does this make sense? Wavelength is distance. Does this answer make sense? Yes. So again, the math is not the hard part. The hard part is, what are my variables? Where do they go? Okay, so let's do another example. Can I turn this off now? Yes. All right, so let's look at the next one. Let's look at 13. We scroll down to the bottom. We're looking at 13. 13 is asking us about energy, correct? So, again, the hardest part is knowing what our variables are. So if we read the equation, it says, what is energy? So I am solving for energy, correct? So what is energy of light? Whose wavelength? What's the symbol for wavelength again?
Wave.
Squiggly line with a tail. Squiggly line is equal to this. And if we look at our unit, is in meters, which makes sense because wavelength is talking about distance. So we're solving for energy. We are given wavelength, correct? So I'm going to start writing I'm going to list my variables, just trying to teach you guys good habits, correct? So my wavelength is equal to 4.06 times 10 to the negative 11 meters. We're good there. Okay, it is wanting us to solve for, well, apparently energy has 3 lines. It is wanting us to solve for energy. So think about our equations. We have C is equal to wavelength times frequency, and we know energy is equal to H times frequency. Can we solve for energy? No. Why can we not solve for energy? Because we don't have frequency. Can we find frequency? Yes, because we've been given wavelength, correct? So first we have to solve for frequency, and then we can solve for energy. So C is equal to wavelength times frequency, correct? So we're doing the exact same thing we did a second ago. Oops. Except this time we know what wavelength is. How do I solve for frequency? Divide by my wavelength. What I do to one side, I have to do to the other. What cancels out? Meters. Okay, so now all I have to do is put this in my calculator, correct? So I'm going to do 2.998 exponent 8 divided by 4.06 exponent negative 11. And we get our frequency to equal 7.38 times 10 to the 18th. What's my unit going to be? Hertz or 1 over S. So now we know our frequency. Are we done? No, because the question's asking you for energy. So now that we have frequency, can we solve for energy? Yes. I'm going to have to do a little bit of erasing. Okay, so energy is equal to H, which is Planck's constant, named after the person who came up with it, right? Times our frequency. H is equal to 6.626 times 10 to the negative 34th joules times seconds. we just found that our frequency is equal to 7.38 times 10 to the 18th hertz. So now that I have written it this way, what units are going to cancel out? Seconds. Seconds, right? We're going to be left with joules, which, if you remember back from physical science, is what we measure energy in, correct? So now all I have to do is put it in my calculator. So I do 6.626 exponent negative 34 times it by 7.38 exponent 18, and I get 4.89 times 10 to the negative 15 joules. So again, not hard. We have to, sometimes it's just easy to flat memorize things, right? You need to memorize the symbol for wavelength, you need to memorize the symbol for frequency, you need to memorize their units, and you need to remember who is a constant and who is not. Once you can do that, the math is easy. It's all that other stuff that's hard. Okay. So, your